Okay, so today we're talking again about properties of exponents when operating with values in scientific notation. And yesterday we did multiplication. Today we are focusing on division. So when dividing numbers in scientific notation, the same type of rules apply. So yesterday we multiplied our coefficients, and today we're dividing those coefficients. Again, we're applying the properties of exponents. So when dividing, we subtract the exponents. So let's take a look at the Jupiter and Mercury example that we just talked about in the book. So we have Jupiter, and we want to divide Jupiter into whatever the size Mercury that planet is. We want to know how many Mercuries would fit into a planet Jupiter. We're going to take our scientific, we know that it's division because we're taking Jupiter and we're dividing it into the size of Mercury. So we're going to take our scientific notation number for Jupiter. So it has a mass of 1.9008 times 10 to the 27th power. And then Mercury, we just figured out, has a mass of 3.3 times 10 to the 23rd power. So here, let's go ahead and let's highlight our coefficients. So anything that's a coefficient, we're going to highlight. These right here would be our two coefficients. And then we've got our base of 10. And again, it's the same base. And our exponent is 27 and 23. Okay. So we would do 1.9008 divided by 3.3. And that would be its own problem. Now, when we're dividing with decimals, we've got to go back to our division with decimal rules that we learned in 6th grade. So here, numerator goes in, denominator goes out. Okay, we can't have a decimal in the denominator for this part. So we go ahead and we move this decimal one time. Whatever we do there, we have to do here as well. So if I move it one time, okay. Okay, so I'm going to rewrite this so it's a little bit neater. I get 33 into 19, and I'm just going to bring my decimal straight up. 33 doesn't go into 0, so I put go into 1, so I put a 0 there to hold that place. It also doesn't go into 9, so I put another 0 there to hold that place. 33 goes into 190. Now I'm going to go ahead and estimate and count by 30s. So 30, 60, 90, 120, 150, 180. So it's somewhere between 5 and 6. I'm going to estimate low, and I'm going to try 5. So 33 times 5 gives me 15 plus 1, so 16. So I'm going to subtract that out, 165. So here I borrow from my 9, I make it an 8. So 5, 2. That's not enough to get another 33 out of. So I go ahead and I bring down my 0. All right, now I'm working into 250. So again, I'm going to count by 30s so that way I know where to estimate where to start. So 30, 60, 90, 120, 150 is 5, 2, 180, and then 7 would be 210. I'm going to try 7. Just going to give it a shot. Okay, so 33, if I add another 66, that gives me 2 33s. I'm going to try it. 11, carry up 1, 12, so 3, carry up my 1, I'm at 231. I cannot get another set of 33 out of that, so I'm just going to subtract that out. 9, 1, 19. Okay, I'm going to bring down my last number here. I'm going to bring down my 8. And so I've got 5, 7. Now I'm going to try, again, I'm going to count by 33s. If I did my math correctly, it's somewhere around 6 because it's greater than 5, but it's less than 7. So again, if I do this math, let me just make some space. If I do this math, 33 times 6, 8 to carry my 1, so 18 plus 1 is 19, is exactly 198. So this would work out to be 0.576 when I did just my division of my coefficients. So now I have to look over here. I have to look at my base and my exponents. My base is 10, my exponent is 27, my other exponent is 23. So I subtract my exponents because I'm dividing and they have the same base. 27 minus 23 is 10 to the 4th. And I can multiply that. Now, if I'm answering this in scientific notation, I notice that I have a big problem with my coefficient currently in scientific notation. And that problem is that this is less than 1. And in scientific notation, your coefficient has to be greater than or equal to 1 and less than 10. So I have to go in, and to properly express it in scientific notation, I have to change a place value. So I would rewrite this as 5.76. And now, because I moved it that one place value, I took a place value movement away. So I would do minus 1, and that would give me times 10 to the 3rd. If we bring this out in standard form, you can see it a little bit more clearly. So here, if I move it 4 place values, 1, 2, 3, 4, my standard form number is 5,760. So now if I put this back into scientific notation, 5,760, I move my decimal 1, 2, 3 times to get it to be a number between 5 and 7, my decimal between 5 and 7 to make my coefficient between 1 and 10. So that gave me my 1, 2, 3. That's how I got my place value, or my exponent of 3, because I moved it 1, 2, 3 place values.